inputs page. These are all part of the default configuration. So this is the state they will be the first time you have a look at the inputs page after uploading the firmware and file system. So in this particular case, then out LEDs are disabled. The mode, move meaning the LEDs are on for the duration of the move, and pulse meaning the LEDs are only on for each step of pulse. A joystick, you have to be aware, if I click enable and there's no joystick connected, the firmware doesn't know that, and so it will start moving the motor immediately because it's checking the state of the input from the joystick. And because there isn't any, the pins float high, which means that it is going to start moving. And it'll keep moving until it hits either 0 or max step. These values called J midpoint, J threshold, these are explained in the PDF, and those figures have to be calibrated using your particular joystick. So once you've got the joystick connected, you can come in here, you can run the calibration routine like this, and away it goes. Click calibrate, it'll give you a whole lot of messages, etc. on a serial port. So you should have the Arduino IDE connected with the serial porter, monitor open so you can see the messages, and then it'll plug you, and once that calibrate's finished, it will come back with another box saying, do you want to apply these into the firmware, at which point you would say yes. Push buttons are quite straightforward, and they can be enabled or disabled, so they're totally separate from the joystick, by the way. In the ESP32 dev project are not. Joystick and push buttons use the same pins, but not here in the S3 Focuser. So if I enable them, that's fine. And the push buttons are active low. So the general state of the pins is they're going to float high. So it doesn't detect a button push until you actually press the button which shorts the pin to ground. The steps is how many motor steps do you want the motor to move for each push button press. That's what that means. And there is a particular formula for working out, and the formula that I use is 1 up to a step size divided by 2. So if your step size was 15 and you divide it by 2, that's 7. So that would mean that you only have a choice of 1 to 7. The reason why this is let's say we made the steps 50 and you're a visual person trying to get a focus and you're moving the motor, and each time you press the button, it's moving 50 steps. And remember, there's a relationship between CFC, the critical focus zone, and how many motor steps you want in it. And let's say the motor steps was 10, and we make this thing move by 50, the chances of us landing in the critical focus zone on any given push button is virtually nil. It's very, very small. So that's why you're restricted to how many steps you can move using that particular formula. Motor page now, and there's a lot of stuff here. This is where you would come, let's just say you've finished uploading your firmware and software. First thing you do is you position the focuser at position 0, and then you go 0 and go set, and then you would have worked out what next steps was, so you can immediately type that in, etc. You then work on the delay to get the speed of the motor to an acceptable level. If you're using a home position switch, don't enable reverse, it'll crash. If you need to be able to reverse the direction when you've got a home position switch, all you do is you reverse one pair of the coils. So if you had a coil pair with was black green, you would swap it over to be green black. We can change the step mode. I can just do that, and I've changed the step mode now, and I've got twice as many steps in the critical focus zone as I had before, and I can set the value of step size. You should have step size enabled. It'll just make life a lot simpler when you talk to intelligent client apps and entering the value of the step size. And again, you would have calculated all of that before. Move essentially is a good way to actually test the movement of the motor. I prefer using move compared to the other one, the previous page. And you can set the various motor speeds. So normally when I set up a focuser, this is one of the pages I come into. I set the position 0 here, and I clamp up the focuser, etc. And then I go to move, and I can set the various motor speeds to make sure they look fine. And I play around with motor step value, going 500 steps at a time to check the smoothness of the motor movement. And once you've done that, that's probably the last time come back to move. This is the links page, and it starts off in the collapse of the various subdivisions. External links are links to the SourceForge project site. And so what we've got is we've got links to zips and user guides and folders and virtually everything you can find here. And the next part is config files, and these are the major configuration files. The controller board holds all the board information, the focuser contains all the focuser information, such as backlash and stuff like that. Var contains the current focuser position, plus the direction of move, and all the board, focuser and position direction type settings are all saved in these files and are regularly backed up and updated as the focuser is working. And for these particular configuration files, if you want them downloaded to your computer, laptop, etc., you just go save link as and away, and that file would be saved. On the management server, well, we've got a heap of things that are additional. There are get set commands. So if, for example, I type this on the command line, I should be able to get back status of Alpaca server. I'm in a browser at the moment. So if I open up another browser window and, oh, sorry. 168.0.1, 142 port 6060 / and what was that command? And that's the command that I wanted to execute. So if I go to the new tab and I type get Alpaca server equals, that's it. And as you see, there's a JSON response here because I currently haven't got it running. So there's all those get commands, and there's also set commands as well, a whole heap of them. And you can access this by curl or Python, etc. So it's another way of controlling your system and your system focuser, or to get information from it. Load nav bar, you don't need to know. Videos, there is a page dedicated to whatever the videos are. These are the ones that have been made so far, and there's more to come. There's videos, there is screenshots. So if I want to have a look at various screenshots that I've done, I can make those available to you. If you click on it, it'll download a zip file and all the screenshots are there. There is xhtml support. So, for example, let me just make this just a little bit bigger. So there's 4 position. If I do this, the position is 5,000. If I do this, the target's also 5,000. Target is only moved. It's false. Is moving. The amount of memory that we've got left over to play with. The signal strength is -39 dBm, and SUT stands for days, hours, minutes. So the controller's been up and running for 1 hour, 15 minutes so far. So in all of these, like I did /PO, and it returns what the current position was. So again, you can use curl or Python to get information from the particular management server if you so desire. File handling now, and this is going to cover files, delete, rename and upload, because they're all files, or deal with their files. So we'll choose files. What files does is it comes back and finds the name of every file in the file system, including the size. So admin move.html consists of 3,981 bytes, etc. So at any particular time you can see what's there. If we knew what a particular file was, we could go to delete. We could type its name in here, for example, and then we could click delete. If it's possible for us to screw something up, we can actually create a backup of that file, and then if it doesn't work, we can come back in here and restore the file by renaming the backup file name that we created. And upload, of course, you would have seen before, is just really simple. It's drag and drop. And you can drag and drop multiple files in here into the file system, and it will go through, and here's ones I've uploaded just today as I'm working through the videos. We're now onto the presets page, and these presets are available to the web server, and you can set them in here, because this is the first time we've powered up the controller after uploading the firmware in the file system. These are set to 0, but I can just go in here and I can do that, and I can change this one change this one as well. You see I've got previous values that I've used during testing as well, and so on. And it's just a simple matter of typing what your presets are in here. You can also do this on the web server as well. At the start of this video, what I did was I showed you config.h in the firmware, and I had OTA server enabled. And so it's come in here and it's automatically started it, etc. OTA is not part of the default configuration, but I had explicitly put it in config.h, and it gets everything up and running for me. And it's telling me it's running on port 999. This is the username and password, and you can change these at any time. So let's go and have a look. I'm going to type in here a particular port number, 1, 2, 3, 4, 4 nines of the OTA server. And notice this, it's now coming saying the requirement is we need authorization on port 9999. And it's asking us for a username and password. And remember that is, of course, we just had the OTA screen up there. So click sign in. And here we are. We've got firmware. We could change this to a file system. And we can have a light one, or we can have a dark one. I prefer dark. These things, of course, are available for the Pro version, and we don't need that. So when we click a particular file here, and this button called Select File, it's going to ask us for a firmware.bin file, and currently I haven't set any of this up, so we'll have a look at this in detail in OTA when we cover OTA. This is the biggest page of all. It's over 10K in length. And this is purely for looking at what the controller is actually doing and what's configured and running or disabled, etc. So I call it system. And if you want to know what's happening with the controller, we go and have a look. It tells you we're running in station mode. The steps per rev is 2056. Fixed step mode was -1. These are all coming from the config.h file, because all of these are captured, you see. And so we have all these things. I'm currently running color scheme 1. MDNS has been defined. We have a name, etc. And there's more for the chip file system, and it tells you what all the pins are being used and what's going on with the actual focuser itself. And there's snapshots, how long everything's actually taken to run. So these are snapshots of how long the largest time that a server actually took to do an operation. And the largest time for the management server was 1.2 seconds. Status of various systems, home position switches open. We're running the temperature, we're running the TCP/IP server and the OTA server, what ports there are. And debug server is running 9090. The OTA server is running on 9999. And the backlash, and it just goes on and on and on. So if you're not sure something's not particularly right, you can come in here and you'll be able to find it here on this page, and it helps you double check whether or not it's working. If I click on save, it gives you this message. Save saves all the controller settings into the configuration files in the file system, and it does that immediately. Generally, all saves to the file system all grouped together and written once, like every 120 odd seconds, etc. That time's configurable, but and that saves us just continually writing to the file system, because over time, you know, this is a bit like a car, an EV car with a battery, or your phone. You can only charge it so many times before it eventually says goodbye to you. So the ESP32 chip is the same. Flash has got a value for the maximum number of writes that you can actually do. So by grouping all of these together and not saving them all individually as they occur, allows us to minimize the number of writes involved. Finally, we have the reboots page, which allows you to reboot the entire controller, individual parts. Let me just go back for a moment to servers. I'm going to start this up and start, and to verify that it's running, just go over here, I type that in, and this is the web server. I know it's the web server, see that? Web server. And this is what the web server looks like, and it has 3 various pages on it, like new page, of course, presets, and remember I said there's a difference on the web server as you go to. Alright, so that's the web server, and back in the management server, I got the capability of restarting it via the reboots page, like this. I could reboot it. Well, let's just go back here and I'll explain this in a moment. Here's the MDNS name, and the MDNS name only happens when the web server is running. So MDNS should be running now. So if we went into system and had a look for MDNS, it would be underneath controller. It has been defined and it's currently running as myesp32s3. We know that's all running, that's fine. And way back here, servers, I started this server and it's running, and I should be able to, the MDNS name is currently myesp32s3. So if I open up and I type in myesp32s3.local, says this, I should be able to connect to the web server, and you can see that now I'm not using an IP address anymore. I'm using MDNS name, and the MDNS name plus .local, and also use that on the management server. Just to show you can do all of this magic way. All right, so that's the management server, and if we just go back prior, this is the web server, and I'm using the MDNS name to do that. Now, if I came in here and I changed the MDNS name, and I tried to use that now, the name is Bob's ESP32, Bob's ESP32.local, and this won't work. See that? It won't work because of the fact that the MDNS name is only set when the web server starts. So we need to go to the reboots page and we need to restart the web server, and that's how quickly it happens. And now we go back to this one and go, let's try that again. And you can see now we're using the new name for MDNS. So what else is there to cover? We've had a look at the commands get and set. We've had a look at screenshots and videos. I did a demonstration of a PO command, which returned position. And if we were going to use curl and to get the temperature, this is what the curl command would look like, and a similar one to get the position. One thing I haven't talked about so far is xrates. Here we have a new page, which we don't have in the previous Focuser versions, etc., or projects. We have things known as refresh rates now. You see down here, it's got a value for heap, and notice it just changed, it just stopped going. And we have a value for, the Wi-Fi signal strength, and we've got a value for the system uptime of 20. Notice these values, the heap, the system uptime, and the Wi-Fi signal strength, they will be refreshed. Notice it just got refreshed automatically without me doing anything. All I'm doing is displaying a web page here, but these values are changing. And the same thing happens on a web server. If we tell it, for example, to go, notice this moving's gone through, right? And it's currently winding its way down to position 2176, and this is all changing, and I'm just not doing anything. It's because this page is using commands to talk to the web server and to be able to update these values in real time. And now that the move is finished, this moving is actually set back to false. And that's all done by using xhtml. Now, one of the problems you got is if you've got a remote observatory, what's possible is that those refresh rates are just way too unrealistic, and they take longer for you to get a response from the other side of the world compared to, your back door. So there are two refresh rates. There is a high priority one, means it's done more often, and a low priority one. And you can set these to whatever you want. So if I'm on a really slow network, I might make this like 10 seconds, like this, right? And then I go set that. And anything that's high is moving side. Sorry, I did the low priority one. So anything that's low priority, it means a refresh of that will only occur every 10 seconds. This is 1 second for high priority. And if I was, again, on a very slow network, I might make this 5. And I make the low priority basically double. So you can muck around with these to ensure that you're always getting the responses and the client's not timing out